Hi, my name is Melissa Daly, and I am going to be talking about standard candles, specifically Cepheid variable stars and Type 1a supernovae. In astronomy, distance to celestial objects is found using apparent magnitude, how bright a star looks to us on Earth, and absolute magnitude, how bright a star actually is. As you can imagine, it's kind of hard to guess a star's absolute magnitude. That's why astronomers use standard candles. Standard candles are stars or objects that have a known absolute magnitude. Because we know their absolute magnitudes, we can calculate the distances towards those objects. We can then find the distance to nearby objects based on the distances to the standard candle. We find distances on Earth the same way. I may not know how far a friend of my grandma lives, but I know that friend lives near my grandma, and I know my grandma lives 15 miles north of my family. So I can estimate that my grandma's friend also lives about 15 miles north of my family. My grandma's house is a standard candle. I figured out the distance to her house, and I can find other distances based on that knowledge. There are many types of standard candles, but I'm going to focus on just Cepheid variable stars and Type 1a supernovae. Cepheid variable stars are stars whose brightness pulsates. They grow dimmer and brighter over a specific period of time. That period of time can range from 1 to 70 days. The period and the absolute magnitude of Cepheid variable stars are directly correlated. The greater the period of time it pulsates, the brighter the star is. Scientists can find out the absolute magnitude this way, and then they can use it along with the apparent magnitude, how bright it looks on Earth, to calculate distance. Cepheid variable stars can be used to find distances of objects that are from 1 kiloparsec, which is about 3,261 light years, to 30 megaparsecs, about 100 million light years away, so a long ways away. The other type of standard candle I'm going to talk about is a Type 1a supernova. A supernova is when a star explodes. Type 1a supernovae are found in binary systems when two stars orbit each other. In this case, a white dwarf and a red giant are orbiting each other. White dwarfs are extremely dense and have a high gravitational pull. The white dwarf's gravity starts to steal mass from the red giant as they orbit each other, as you can see in this picture. This is the red giant, the big one, and the white dwarf is that little one. As you can see, it's starting to steal its mass. When the white dwarf reaches a specific mass, it can no longer support itself and it explodes. Type 1a supernovae are standard candles because they all reach about the same peak brightness after their explosion, and then they follow the same curve as they decrease in brightness. So we can use them to measure distances. We can find distances with Type 1a supernovae out to 10 billion light years. So thank you for listening to my presentation on Cepheid variable stars and Type 1a supernovae.